दो दिन पहले 1.5 दिन चला मेरा मोबाइल।
बस यार क्या करें।
Okay, so we are discussing that how the authentication header is used to provide the authentication to the data, or it is used to identify the tampering of the data, or it is used to identify the, you can say, if any data is modified by the protocol, or if any data is modified by the intruder or by the attacker. So if it is actually this contains some information like integrity check values, or it contains information about the protocols which are used to provide the information about securing the protocol, or securing the, you can say, data or packet that is sent it from sender A to sender B. So it's actually the way of sending the data. So we have different, you can say, different attacks they are involved in this situation. So we can protect the system from such type of attacks, like if the attacker can apply a replay attack, or attacker can use a spoofing attack, for example. So if, for example, here he can use a, he can say, he can spoof the IP address of a particular host, and then he can use that IP address and can send the data to other hosts. Or for example, he can use the same message or same packet, for example, and can send the data to other hosts. So in this way, he can use this these different methods and these different, you can say, uh, um, mechanisms can be applied by the attacker to attack to the system. So in order to protect the system from such type of attacks, we need to require the encryption of the data, or we need to require the authentication to the data, and that is provided using different protocols like MD5 or SHA1. And for encryption, as far as encryption is concerned, so it depends on the which type of encryption that is used. Either it is a Semitic encryption or asymmetric encryption. If we say that is a Semitic encryption that is provided using a DAS or AES algorithm, or if we say that it's asymmetric encryption that is provided using RSA algorithm or some other algorithms like electric curve cryptography. So they are the different protocols or the different algorithms are used to provide the security at this layer. Now, as we are discussing about the architecture that is used by this protocol, so particularly we say that this is the this figure further explain that's a database, security association database, and that is actually the protocol which contains information about different fields, like which is related to the authentication header, like for example integrity check value, which is related to authentication header, which identifies if any data has been modified, any packet has been modified, so that would be identified by the integrity check value. So that will that will add some value to the packet. If any value, for example, at the receiver end, we recalculate that value. If it matches to the value that is received by the receiver, that means it's we can say it's actually the data has been securely received by the receiver, and that is not modified. So in this way, with the help of that field, we can do this and we can use that using the integrity check value. And then we have further information that is required to secure the information or secure the data in the authentication header, for example, that may use a different protocols as we discussed. It may use different hashing functions, or it may use some other methods like uh, ICVR integrity check value to identify particular you can say error or particular data which has been modified. So if it contains that information, that means the particular packet is not being modified or the particular packet is not being changed. So we can identify that with the help of the integrity check value. So in this way, it contains different information about that. So we can also prevent the data, prevent the spoofing of the particular address, for example. So with the help of this field or with the help of this method, we can also protect the data from spoofing attacks, and we can also protect the data from replay attacks. So in this way, we have a different fields here which are used to provide different I can say security to the packet or to the data, for example. So we also discuss about different modes like the tunnel mode and the transport mode. So that is used both in the IP version 4 and IP version 6, for example. So it is attached, it's aids the header to the packet, for example, and that packet is added to that header is added to the packet, and which contains the information about the packet, that either that packet is actually can be securely sent it to other system or not, or it contains if it matches to the particular policy, for example. So if it need to be accessed to the system or not, or if it is not need to be given an access to the system or not. So in this way, we have a different header information, and that header is attached to the original protocol, and which contains a source address and destination address, and which also contains the information about the algorithm that is used to encrypt the data, and which also contains the information about the algorithm which is used to provide the integrity to the data. So with the help of this header of the IP security protocol, we can provide the integrity as well as we can provide the authentication to the data. And then we are discussing about the encapsulation security payload. So it provides a message confidentiality as it is used to encrypt the data. So whenever we are encrypting the data, so then we need uh, this part of the IP security protocol, which provides a security in the way of providing the secrecy to the data, or by the way of providing the confidentiality to the data. So it can use a different protocols in this here, like it can use a DS algorithm, 3DS algorithm, or some other algorithms like AES algorithm to provide the security, or if it is using a asymmetric encryption or public key encryption, then it can use a RSA algorithm or ECC algorithm. So in this way, it provides a different security at the different layers. So for providing the security to the data, security functions to the data, so it uses a security header that is called the encapsulation security payload. So we can provide the security by providing the features like authentication, or by providing the feature like encryption. So with the help of authentication, we use authentication header, and for providing the encryption, we use an encapsulation security payload. So in this way, we have different fields and different headers for that. And like for example here, this discuss further that how the encapsulation header is used for adding the security to the packet. For example, there is a encapsulation header is added here, and which is used to provide encryption to the data, and that is using different algorithms or different protocols for encrypting the data. So that would be the symmetric or asymmetric algorithms, as we discussed. Different protocols are different uh, protocols for symmetric encryption and different protocols for asymmetric encryption. And then we have the data, as we discussed. That is outbound data, and there's inbound data. The data that is in the network and that is sent it to other network, that is inbound data. That is data there's out of the network, and that is allowed to enter into the network, that is called the outbound data. So we are defining different policies for those. Like for example, we can define policies for the outbound packet, uh, and we define the policies for the inbound packet. So these different policies, as we know that the different, you can say, security parameters are used, which define the different policies for the particular packet, for example. And each packet is sent from a host to another host, that defines a sequence number for that in which sequence the packets are sent, and it also add some other information related to the encryption also, and it also add the information related to authentication. So in this way, we have different protocols which are used to add the data to the packet, or add the fields to the packet, which are required to provide the authentication and which are required to provide the encryption to the data. So in this way, we have different fields are used, which are important to provide the security to the data. So this figure further explain what are the different fields which are used to aid the security to the data. Like for example, as we are discussing the mainly related fields which are used for the data, that is like for example, security parameter index and integrity check value. So these are the fields which are used for the IP security protocol to provide the security to the data. And whenever we want to provide the encryption to the data, so we provide the encryption to the data using a payload, ECB transport payload, to provide the security to the data. So this figure explained that how we can provide the security to the data using an authentication, or how we can provide the security to the data using a protocol like IPSecurity protocol. So we have inbound packet processing, inbound packet that is need to be that is in the packet, and that is need to be send it to the other network, for example. We can define that either that particular packet is need to be given an access or not, or it's a packet that needs to be that should be allowed in the network, or that should not be allowed in the network. So in this way, we can define different policies for that, and we define different policies which are in the list of the database, like security policy database that is associated, that is attached with the IP security header, and which contains information about different packets, that either that particular packet is can be given an access to the system or not. So it's also very important that when we are defining the sequence number for particular packet, so it is also very important to know about that either packet, that packet is a already has been received, or it's duplicate packet or not. So if it is a duplicate packet, then we discard that packet, for example. So in this way, we can use different policies for the packet. We can use different policies for the encryption. We can use different policies for the authentication using different fields which are attached to the packet. And when we add the different policies for that, so according to these policies, each packet is actually accessed into the system. So if it matches to that particular policy, then it will be accessed to the system or given an access to the particular network. So then we have some other topic like network address translation, that is used to translate a particular address to another address. For example, as you know that when we are sending the data to other network, for example, if it is using a IP address that is used by the network locally, for example, and that is used to send the data to other system to in the same network, for example. And then if we want to send the data to other system which is in another network, for example, then we need to use an IP that is a public IP address. So for example, they are the limit, they are the number of public IP addresses which would be assigned to the particular network or particular device. So whenever any data is sent it from a private network to the public network, or the data in the organization, for example, to the device or to the network that is in another network, so then it uses a public IP address. So in this way, whenever any data is sent it to our other network, so it needs to be mapped into the public IP address. If it is using a private IP address, then it would be mapped to the public IP address, for example. Or if it is coming into the network, then it would be mapped to the private IP address. So in this way, the network address translation or the NAT is used to map the different IP addresses between the public network and the private network. So they are the different types of, we can say, network address translation are involved. Like for example, we can translate particular IP address to the IP address. For example, we can translate the private IP address to the public IP address, the public IP address to the private IP address. Or for example, we can use a port numbers. For example, that particular we bound a particular port number with a particular IP address, for example. So in this way, we can make the IP address with the port number as well. For example, if we say that if that particular IP address, if any data is coming that is having that particular IP address, so that is accessing that particular port number to that is need to be mapped to that particular port number and can given an access to that particular application to the data or particular protocol to the system or to the network. So in this way, we have different types of information that is used to send the data to other network, and we are required to send the data to other networks. So the IP addresses are involved here to send the data to other network, and they are made between private to public IP address and public to private IP address. So in this way, we have different information as this figure explained further about this type of address translation. For example, if they are the hosts which are here and they are having different IP addresses, for example, and they want to connect to other network, and There are the different IP addresses for the, you can say, public network, for example, here. So if any of the hosts is getting an access to other network, for example, then it can uses that public IP address to send the data to other hosts, for example, because actually when we say that um, inside the network, they are the private IP addresses are used, and they are the outside the network, they are the public IP addresses are used. So when any data that is sent it to other network, that is translated or that is mapped to the public IP address, or if any data that is coming into the network that is mapped to the private IP address. So in this way, the network address translation is used, that is done by the router, for example, to translate the IP addresses between a host to the network, or network to the host. So in this way, we can do this with the help of the address, as we are discussing. That type of IP address is used to provide the different functions of address translation. So if you have any question about this, then you can also ask. Yes, is there any question? Is there any question?
I have a question.
Yes.
Sir, you told that authenticate header is a modified by the intruder or hacker. Sir, define this in a simple word, sir.
Uh, Actually, I say that the the intruder or the attacker can modify the data or can change the data. So we are using the authentication header that contains the information about different protocols or different algorithms which are used to encrypt the data, or which are used to provide authentication to the data. So when we provide the authentication to the data, or when we provide the encryption to the data, so we are using different algorithms for that. So for example, if we are uh, providing authentication to the data, or we are providing the integrity to the data, we can use some protocols or some functions like hashing algorithms, like for example MD5 or MD4, or some other functions, hashing functions, which are used to provide the integrity. So in the authentication header, so the attacker is actually can modify the data or can change the data. So it is not concerned with the, you can say, header information, but the header information contain the information that is used to provide the security to the data, that which algorithms are used to aid the encryption to the data, or which protocols are used to aid, uh, you can say, I can say, integrity to the data. So in this way, that is providing the information about the protocols which are used to provide the integrity to the data, and that contains the information about the protocols which are providing the data, that information related to the data, so that the data will not be modified or the data will not be changed. So if any change is identified in the data, or if any change is made in the data, that would be identified by the intruder, or that would be identified by the attacker.
Okay, sir. And sir, what's the difference between integrate check value and message authentication code, sir?
Uh, Message authentication code is actually the code that is uh, that is used to identify if any change is done in the data. So for example, it creates some code from a message, for example, or from a data, for example, and if that message is actually uh, changed or modified, then it would be identified with that value. For example, it works like that. It is there's a message, and there's a message authentication code, and that is attached with the data, which is sent it from host A to the host B, and when it is received by the receiver, so the receiver recalculates that message from the message authentication code from the message. So if it matches to the original message, that means it is actually, we say that it is actually the data or the message is not modified. But as far as the integrity check value is concerned, so that is attached with the packet, and that is used to you find out if any error occurs in the data, uh, then it would be used to find out that thing in the data. So that has a different purpose in the sense that MAC is used for identifying uh, the change in the data, and the integrity check value is used to identify the error in the data.
Sir. Sir, you told that the encapsulating security payload is providing the authentication, integrity, and confidentiality. Sir, how we do IP4 and IP6 authentication, integrating, and confidentiality, sir?
Actually, we when we use the protocol like IP6 and IP4, so when we are using the packet that is using IP version 6 or IP version 4, for example, so that if it is using the IP security protocol to provide the security to the data that is used to send to other network, for example, so then it will aid the security to that. So it will aid the encryption to that. It will apply some hashing function to provide the security to that. So we have to define that we are using the IP security protocol with the packet. So if we use the IP security protocol with the packet, then it will aid this security functions, these security functions to the data. Like for example, it will aid the authentication to the data, or it will aid the security function, like for example, in encryption to the data.
Yes, sir. Thank you, sir. Sir, and you told me that NAT network addresses translation is a process which one IP address convert to the global IP address, sir. How we understand this point, sir?
We say that here global IP address, that means the public IP address. So
Yes, sir.
whenever we say that if any data is sent it from a private network to the public network, private network here means the network, the organization network, or any organization network, that is private network. Or public network is we say that internet, for example. So that is a public network. So if you want to send the data from a private network to the public network, for example, so there is a network device, for example, router or gateway, that is used to send the data to other networks. So what happens that it contains a list of the public IP addresses, and whenever any data is sent it from a private network to the public network, that it will use the public network IP address, and then it can send that public IP address to other system. So actually what happens that if any data is sent it by other user to that user, so he will use that public IP address to send the data to other user. Then ultimately when it comes to the router, for example, so then it will convert that public IP address to the private IP address, that is a private network IP address that is used by the network. So in this way, that is actually the method that is applied to send the data from host to other host, or that is a method to send the data from network to network.
Sir, can we say it's a vice versa?
Yes, sorry.
Sir, can we say that it is a vice versa?
Vice versa.
Means it's a, sir, if a global address it's the same, or what's the difference about, sir, a local IP address and a global IP address, sir?
It is if you have studied about the IP addresses, that there are the different classes for the IP address, and we use a specific IP address for the private network, and we use a specific IP address for the public network, for example. And the public IP address is used by the internet, for example, and the private IP addresses are used by the private networks, for example, because we have so many private IP addresses, and we have different public IP address. Because we are using the private IP address within the network, so it could be same for other network also. It could be some other network that may use same private IP address, but as far as the public IP address is concerned, that is a unique IP address, or you can say that would be you cannot use that IP address, for example, for other network, for example, because every network then will be identified with that IP address. So that is why we say that every network has a unique IP address. That is a public IP address, but as far as the private IP address is concerned, so we say that every IP address, every network has its own IP address. So it's possible that there would be some other network or some other organization that may use the same IP address which are used by other private networks. So in this way, the private IP addresses can be used by many networks, for example, or the public IP address can be used uh, by a single network, for example. And each public IP address is a unique IP address that is given to the particular network.
Okay, sir. And sir, give me the example static and dynamic network addresses translation, sir. It's a type of network addresses translation, sir. Static, dynamic, sir.
So it's like that when we are manually defining particular IP addresses, then it would be
Sir.
static. And when
Yes,
we
sir.
are using some protocol, for example, like dynamic host control protocol, so they are giving an IP addresses dynamically to different hosts. So then we say that that is dynamic IP addresses.
And sir, port address. The last one is port address.
Yes, that I say to you that the IP address can be mapped to other IP address, like it can be mapped to from public IP address to the private IP address, or for example, it can be mapped to the public IP address to the some port number which is related to some application. For example, we say that that particular IP address uh, will access to that particular application, for example. Then we map that IP address to that particular port number or particular uh, address of that particular application. That with this, if we are using that IP address, then it will use that particular port number. So in this way, we can map the IP address with the port number as well.
Okay, sir. Thanks so much.
Okay, so that's all about today's lecture. So we will further continue this lecture in the next class as well. Okay, okay for now.